Fantastic. 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 I don't know where it could be coming from. You're on headphones. Laptop's on mute. I don't know where it could be coming from. You're on headphones. Laptop's on mute. I don't know where it could be coming from. You're on headphones. Laptop's on mute. You're on headphones. I don't know where it could be coming from. You're on headphones. Laptop's on mute. You're on headphones. I don't know where it's. Good. Okay. All right. Shall we do this?
All right. Sorry about that, everyone. I've been fighting audio issues for like the last 20 minutes. So we're still getting used to this whole Twitch thing, but we'll get there. So great. So let me know if there are any audio issues that you all hear. There's some serious reverb. Yeah, hopefully, I think it was coming from me. Hopefully I just fixed it. But let me know in the chat if it's still happening, and if the music is too loud. I'm not sure if it is or not. But go ahead and get started. So we've got Gabe Peal here today. Gabe, thanks for coming on. Some of you might not know, but Gabe and I used to be colleagues. We worked pretty closely together for 3 years almost. And
yeah.
And so it's kind of cool to be probably 3 years since we worked together, and we've both kind of moved on to different things, but Gabe is hugely active in the Android community. Got his GitHub pulled up here. This is one hell of a contribution graph.
I don't know if that's something to be proud of or embarrassed for. I'm not sure.
Yeah, I don't know, but it gives me some envy. But so Gabe, so you maintain MvRx and Lottie, probably as your two higher profile projects. Can you tell us a little bit about those?
Yeah, so they're two open source libraries for Android that I worked on when I was at Airbnb working with Leland. Many of you might be familiar with them, but Lottie is After Effects to JSON to mobile animation renderer and framework, and then MvRx is built on top of Android Jetpack. It's an Android architecture library that we're going to talk more about today. I'll be monitoring the live stream, but just if you could maybe type in the stream whether you've used MvRx before or if you have any familiarity with it, that'll help us understand at what level to talk about it. And there's a little bit of lag, so we'll keep talking, but I will keep an eye on it.
I see Felipe in the chat. Felipe, it's good to see you. Another earlier colleague. Okay, so Gabe and I were talking about like what we could do for this, and our thought was kind of like we would just try and pair program. We've got the MvRx repository has like a counter example, which is like a really simple example. We actually wanted to do there's a dogs sample app that's a little bit more involved, but we ran into some build issues, so we're just going to do the counter app at least to start, and I think that'll still give us like a pretty good chance to see what we can do. So right now this sample app uses MvRx, but not Compose, and so
and not only does it use MvRx, it's actually using the early beta builds not so early anymore, for MvRx 2.0. So if you're familiar with MvRx, you might see that it has a slight name change from MvRx to the full name MvRx. And that's because 2.0 was completely rewritten internally to use coroutines instead of Rx Java. It was probably the most common request we got was to be able to use MvRx without the Rx Java dependency. And given the direction that things are going in the Android community, my guess is that that number is going to be increasing over time. And for a new project, you may never need to add Rx Java at all. So we wanted to make MvRx work well for those cases. For all intents and purposes, it's philosophically the same. It's structurally the same. The name is changed just so we don't scare people off with Rx, which is now considered old by the community. And a lot of people were actually not even willing to use it because they saw that and they're like, oh, it's old, it's Rx Java, I don't want to touch it anymore. So there you go, we changed the name for you. We also rewrote the whole thing. But philosophically, it works the same. It's just all coroutines now. So things like disposables or jobs, subscribe is on each, et cetera, et cetera. So if you have any questions, you can type them in, but it should be pretty familiar. And then for just as a side note, if you are going to be upgrading from MvRx 1 to MvRx 2, there is an Rx Java artifact that is completely backwards compatible. So it should just be a drop-in replacement.
Sweet. So, sorry, I was distracted. I was adjusting your webcam a little bit. Okay. Well, so why don't we just go ahead and get started and see what kind of stuff we can do. Let's say, let me just build and run it real quick, so we'll see the app kind of in its current state. One quick note is I had to add. You can see from the Git lens here, but I added this because the previously you were using the Kotlin synthetics. And that isn't currently compatible with the IR compiler. So I just had to sort of generate the equivalent here.
Well, we're getting rid of it anyway, so I hope.
We are using Code With Me. Yeah, the new IntelliJ. It's sort of like an EAP thing. So.
Yeah, so we can both control. So I just deleted an annotation there. Because it's just going to distract from the sample.
Cool. Sorry, this is building for the first time, so it's taking a minute. So Gabe, maybe to help me out a little bit. So in here we're inflating the layout, and then in onViewCreated, you're just instantiating the listener, which is then going to call this increment count method on the view model. And then in here, this is kind of like this invalidate method is sort of like the moment that you update everything in your UI to be in sync with whatever state has changed. Is that right?
Yeah, exactly. So at a high level, your screen in MvRx you think about your screen as a function of state. It's a lot more robust than thinking about it as a function of events. And so if we have a simple counter with a number that you click on it increments, that screen can be modeled as a function of state where there's one property count that's an integer. So here we've instantiated that, and with MvRx, just as a quick recap for those who aren't familiar with it, there's a MvRx view model. This is a Jetpack view model, so it has the same life cycle. It looks and behaves very similarly to it if you've used that, with the difference that it's generic on a single state class. So it's generic on our counter state class, and it's responsible for handling any updates to that state. So if we move on down, there's this function inside of it, increment count. So the only way to mutate state is from within the view model. So we've created a function here called increment count. These are like our actions. Sometimes you have like a big reducer with a bunch of action types. Well, a named function behaves kind of like an action in MvRx. It exposes the things that you can do to the outside world. So here, if we call increment count, it calls set state, and then it increments the count by 1. Go ahead and leave a comment if you're not familiar with the Kotlin syntax that does this. And then just as Leland was saying with the onViewCreated here, moving up, we get the view model in a way that's very similar to by view models is part of Jetpack, but we give it a scope here. So we say activity view model. You could also say fragment view model, target fragment view model, parent fragment view model, all these Androidisms to tell where the scope of this view model should be. Here we've just chosen activity for no particular reason. And then we can call increment count every time you click it. And then it's automatically going to, MvRx will automatically subscribe to the state changes on the view model in a lifecycle aware way, and then call and validate. So then we're going to get the state from our view model. If you're not familiar with any of the specific MvRx syntax, you can check out the documentation or again, post in the Twitch comments. But here's where we're responsible for updating our UI. So this is the one function where we do all updates anytime the state changes. One of the philosophies behind it also is that your views are idempotent, which means that you can set the same state on your views over and over again, and that's not an expensive operation. So if you set the text and then set the same text again, that should be a very lightweight operation. And things like epoxy and compose work pretty similarly.
Yeah, nice. So I'm imagining like if we integrated this with compose, then we wouldn't really need this invalidate method because the composable function itself would just be that. Does that kind of match your expectations?
Yeah. Yes.
Okay, cool. All right, well, let's I don't know, let's try and convert this over. What are you thinking?
So the first thing we need to do is just think about sort of philosophically or structurally where do we want to get a view model and where do we want the state to be, and then we can create our composable functions from there. We could potentially do this incrementally. Like right now we have a fragment and the view model is created there. We could still live in the fragment-ish world and maybe still get the view model from there and then provide the state down into the compose view tree. Or we could do something even more compose-like and be able to retrieve and subscribe to state changes from within a composable. I've played around with this a little bit in advance, so I think it's possible to do it either way. We could potentially do it both ways and talk about the pros and cons, or do something. I'm really curious to know if you have any other ideas for how you would do something like this. And for the people on the stream, we haven't discussed previously exactly how we want to do this. Kind of intentionally, we want it to be organic so that we can actually really discuss our thought process and pros and cons and go through the motions, because we are all learning Jetpack Compose at the same time.
Yeah. We wanted this to be like, just a real honest conversation and not, scripted or anything. So, I mean, my like immediate thought is like, pretend like this is just a normal fragment. So it's no longer a MvRx view. And so then in here, like we would do, like, and you could do this anywhere. I'm guessing this will be available. And so then here we can like kick off our composable. So we're in this composable world at this point. So let's instead imagine that we've got now a counter. Let me see. Then like it would be nice to be able to get the view model. So basically the MvRx thing just becomes the view model at this point. And not necessarily the MvRx view, which I guess is mostly to give you sort of the ability to specify what the life cycle you're looking for is, right? And then so like maybe we'll do that somewhere in the composable itself. So equals and then something here, right? And then this will do our basic count. So like let's see. count, and then this could be like counter VM dot count. Will that be available?
Yeah, so we'd
Or
want to
is
get the
it
state.
state?
There's both a view
state-
model and the state.
Oh, I see. Okay, so this could be like, and then state.count and VM dot increment count.
Yeah,
Something like that.
something like that.
So then we would just need to create that.
I have a snippet that will do something like this. Just paste it in and we can talk about it. Or do you want to try to?
Yeah,
build
sure.
it up
No,
from
if you've got a snippet, let's go for it.
All right, and then you can tear it apart. Tell me why it's wrong in a million ways.
Tear it
So
apart.
let's see.
You can send it to me and I can pull it up in code or something. Or I guess you can just paste it in here. Yeah. Yeah. Yeah, Gabe doesn't know this, but I'm actually interviewing him right now.
Let's see. So.
Oh, by the way, I forgot to show the actual built app. So this is let me pull up Visor. My computer is struggling, so I think this is kind of interesting. I think that Code With Me is taxing my machine a bit more than at least what I was doing yesterday. Although also I have 2 instances of IntelliJ open, which is also a bit extra, so that's part of it. But okay, so this was our counter, which working slowly.
We did a bunch of renames from MvRx to MvRx to MvRx recently, so.
Oh, are you updating your snippet? Oh, I didn't see it until now. Okay.
Here we go. Yep.
All right. Oh, did Twitch freeze? Let me know on the chat if anyone from Twitch can say if they can see the stream or not. No, it's just slow. Okay, that's a bummer. I think it's probably my machine. I'm at 85% CPU right now. Okay, stream looks good. All right, MvRx view model and state. So okay, so this did this return a pair always, or did you just do that because I did this?
No, that's actually what it did. As you were typing that out, I was like, did you read my mind? Or somehow see this already?
Okay.
That's the API that it already had.
That's funny. We're all using our Reactisms. Okay, so you grabbed the current context.
Yeah.
And then view model provider. Is there, I mean, you could put this, is this just a static? Like, what's the difference between this and a normal view model provider? Like, what is this?
MvRx has some additional hooks because there's a new mocking artifact in 2.0 in which it can sort of hook in and set up mock state and freeze state updates. So you can do things like take snapshot tests and build custom launcher debug applications with your screen in certain states. So it's a fancy view model provider that does some additional things.
Okay. So we could get, I think there's like a, think there's a view model provider ambient.
There is. So for those of you who are unfamiliar, there's a notion of Android ambients, which are, you might have seen one there, context ambient, which are Android specific ambients that are provided by the standard components like fragments and activities. Leland, do you want to explain what an ambient is for people who might not even be familiar with that yet?
Sure. Yeah. So ambients are basically a way to provide. We almost call the ambients tree locals. So you can kind of think of it as like a value that is scoped to a part of the composable hierarchy. And so one like, just like as an example or something, like I could create like a user ambient. And so when you define an ambient, it's like an ambient of a certain type. Computer's pretty slow right now. So, and then in this case, when you do this, you want to provide it a way to give like a default value. And so if user like doesn't have like a good default value, it might be like a good idea, for instance, to like make it nullable. And so then like null could be the default there or something. And then we can just imagine that we had a class. I can't spell. Might be easier actually to just do this in Visual Studio Code. So we don't get distracting error messages. But so you can imagine that we have this like user ambient. And so then if my user ambient would have a current value. And so current here is a composable property. So you can only call it inside of a composable. And so then this will be of type user. And so then the idea is that like if no one above you had provided an ambient, then you would end up getting the default value. But you can provide it like this. So I can say user ambient provides, and then I can give my current user, and then I can call other UI. So some screen composable, and the idea is that like any composable down the chain, down like the call graph, will end up having this user be provided to them when they use user ambient at current. And so it's not a mutable like value. It's like static within that like composition for that part of the tree, but you can change it over time, in that I can change which user I provide over time. And that's basically it. So if I use the current value, then I end up subscribing basically. So I could, if anything below this, if anything inside some screen uses the user ambient, then whenever I change the user, that composable will get recomposed. And that's basically the idea. Let's go back over to IntelliJ.
Hey, Lillian, could you add that import for get value on state, the delegate?
Yeah, this runtime bug is really...
Well, we're going to walk through some of this stuff in a second, so you can see what this looks like in a really composy way.
Okay, so is this view model provider, is that like always available globally like that? Is that like the right way? Yeah.
Yeah. So with MvRx 2.0, you initialize it when the app starts, and if you haven't done that, you will know right away the user app will not run.
Got it. Um, Key factory. What is that?
The key factory, it lets you, if you need multiple view models of the same class in the same view model provider, it lets you provide a custom key. But by default, it's based on the class name. I think Jetpack view models has the same notion where you can provide some sort of a key, so you can have multiple view models of the same class in the same store.
Okay. All right, and so then you're collecting state here. So this is a MvRx thing. It's like so does the view model have a state flow property? Is that the idea?
Yeah, so this is an interesting thing where there's like a little bit of a disconnect between Compose and MvRx. So MvRx's notion of being able to get state synchronously is somewhat of an interesting one. So in MvRx, when you set the state, it doesn't actually update it synchronously. That reducer gets put on a background queue that gets processed on a background thread. It's one of the ways that MvRx can help reduce the load on the main thread. But that means if you call set state and then immediately try to access the state, it might not reflect the state that you just tried to update. So if you're inside of a view model and you call with state, which is how you get the state, it puts that on the same queue and ensures that all other state reducers have been called before it calls your with state block with the state. So that means from within a view model, you can't actually access the state synchronously. However, on the outside of a view model, you sometimes have to, just the way that UI works and certain things like analytics or updating views, you really need to update it synchronously when that state change happens. And so the with state, when called from outside of a view model, does actually give it to you synchronously. So it's not super ideal. Ideally, like when MvRx is written, you would never be able to get it synchronously. You would only be able to get it when it changes with the latest value. But due to some practical reasons, we had to provide that ability from outside of a view model. So jumping over to the Compose world, it seems like one of the common ways to get state from your business logic into a composable tree is through a state flow. So if you have a state flow, if you're not familiar with state flow, it's like a behavior subject from the RxJava world. It emits events over time, and it holds some sort of initial value or latest value that you can synchronously access. And this makes sense for Compose because whenever you need to create your tree, you always need to have some state to render, at least initially, and then again every time it changes. So here in MvRx, on line 54 of counter fragment, there's this we're calling state flow on the view model. So the wording here is a little confusing. This is actually a normal flow of states for MvRx. It's not the state flow from the Kotlin sense. So it doesn't actually have synchronous value that you can get, right, although it does emit the initial value right away. Then we collect it, but because Compose needs an initial state, and it's not a state flow in the Kotlin coroutine sense, we have to pass it initial value. Then we use the with state version from outside of a view model to get that state synchronously. Does that make sense? I feel like I may have lost a few of you on that explanation.
Yeah, it makes sense to me at least. So a few things that you might not totally know. So one aspect is that like state kind of works in a similar way in Compose, and that when you mutate a state object, it doesn't get reflected in the UI immediately. It gets queued just like in the case for MvRx. But the difference is that state objects have like snapshot isolation, and so if you're in code in the thread that is currently doing composition, you'll be able to see the updated state object, but code on other threads or other like realms will see the unupdated value. So it's like a little bit little bit weird, and it doesn't currently impact the way you do things that much, because for the most part, Compose code right now operates single threaded. But the idea would be that we'd be able to run a new composition in a background thread while potentially running a different composition in a different thread, and they would just have different snapshots that they'd be looking at for state.
Got it. So let's keep going through this example, and then let's see what the API looks like structurally, because on line 64, it looks like we've started to come up with the API you'd use from Compose land, which is what most people interact with this with. So let's get this example working, and then we can start to talk about how this is going to interact with Compose.
Sure. So in this case, I would pass in like counter view model.
Issues. Let's get those cleaned up. Get it all green first.
I'll let you work on the green.
I'm trying to import it from my side. I won't actually import.
Oh, it's pulling it up on my screen. Funny enough. All right, there we go. I imported it for you.
Thank you. Yeah, wouldn't let me do that. Yeah, this is JetBrains Code with Me. It's a new early access preview of a pair programming plugin for IntelliJ. So we're giving it a shot. I can actually see Leland's IDE on my computer and do most things. It feels kind of like IntelliJ Lite, where it looks and feels like IntelliJ, but then every once in a while something doesn't work.
Every once in a while.
So then, yeah, I think that line 49 is from the runtime type extension.
What's that?
The get value on state. The import that
I put it in there though. So it's imported and it's being used.
Actually, I think here we can just do.
Oh no, this is MvRx state. What is that?
I think actually we're doing it twice here.
That's why.
We're actually doing it there. There we go.
Yeah, okay.
Yeah, we were doing it twice. Okay. Okay. Yeah. So let's get this to a working state, and then we can see what it looks like and fill in any gaps that we feel like might be confusing.
All right. Well, it looks green. Do we want to try running it?
Yeah. Sure.
Let me just throw this in a column real quick. Okay, yeah, let's give it a shot. Yeah, that goes.
Pretty cool if this just worked.
See a few people on chat saying that it's pretty laggy. Not sure what we can do at the moment to help that. I'm taxing my MacBook Pro to the extreme.
Ooh, I bet it's throttling.
I don't know.
Do you know the thermlog command?
No. Hey, wait, let's see if this works. Oh, it works. Okay, so increment.
Okay. How about that? How often does your code work the first time?
We've won. We've solved MvRx and Compose integration.
Okay, great. So amazing. Let's go ahead and delete a bunch of the extra old Android View stuff here, like that, and then kind of look at what the sample looks like in Compose land.
Yeah.
It's pretty nice, actually. And yeah, we can remove MvRx View here.
Well, and then this would all be MvRx code. So let's move this down so we can separate like user land code versus the like integration. So So like basically, and I mean this fragment here, like the fragment sort of becomes unimportant. Like this ends up being, you know, just counter fragment is just something that composes counter. So then at the end of the day, you basically have this, which yeah, looks pretty nice. And so let's, just for comparison, let's like, let's like do something silly, like, so here we've got this, and so let's just do like the raw state equivalent, and talk about like some pros and cons maybe. Import. So then this would be count, and then count plus plus. So I mean, you can kind of like for a counter, it's a little bit maybe even overkill to have all this, but you can see how this would grow over time, right? Whereas this, it seems like would be a little bit harder to scale if you started having more than just a count that you were managing. Can you move the emulator? Sorry, yeah.
Yeah, one of the things, probably not for this episode, but in a future one, we could talk about what dependency injection might look like and get to some of these more advanced use cases. Just things that come to mind initially, something like a view model. It's really easy to wire that into Dagger or Coin, or then in a test, you can pipe in all your dependencies in a compile or type safe way for testing. But maybe totally possible with Compose, but something to store in the back of our minds for a future discussion, I think.
Yeah, what happens if the phone rotates?
Exactly. So good question. And I'll do the MvRx answer, and you can do the Compose answer, Leland. On the MvRx side of things, it's the same concept of the way Jetpack view models works. So there's something called a view model store, and it's magically stored in what's called a retained fragment under the hood. You don't really have to the word fragment or retain scares you. It's totally an implementation detail, but effectively what it means is that it's created once when your fragment or activity is created the first time. Nothing happens to it across rotations, so it retains its instance across configuration changes. It goes through no life cycles or anything, and then the next thing is that it gets destroyed the very last time, and only the very last time the fragment gets destroyed. So and then in the delegate here, where we call into that view model store through the view model provider, it will return the existing instance if one exists. So if you rotate a fragment or wind up in a totally new composable, you're requesting a view model of the same class, and it'll return the previous instance. So anything you do, like a network request, database transaction, happens completely independently, and you just pick up right where you left off. It's kind of one of the nice philosophies of having this notion where your screen is a function of state, because when you rotate the screen, you get the same view model back, you get the same state back, and you never have to worry about handling rotation or persisting things or anything like that.
Yeah, so I just tried it. If I don't know if everyone saw that, but I rotated the phone, rotated back, so we've preserved the count here. And so if we were to use this example instead, that would not happen.
Leland, how does remember work? Where is that stored magically?
I'm curious. Are you asking for the benefit of the viewers, or do you not know?
Both. I don't know.
What's a better? Let me read this comment first. What's a better approach for scalability? Separate composables which include their own state only, or one view model where you aggregate the states from individual composables? separate composables include their own state only. I mean, so I think that you want to like use state in composables for things that are it's state like inherent to that composable. If it's like a UI state or something, and I think that if you're talking about, I guess what I would call in the realm of like application state, and in this case, like the count here is application state. If we're building a counter, and that's like the whole point of our app, then the count here is like the application state. But you know, how the ripple works in a button or something, for instance, or if you wanted to start having something happen based on like scroll position, and like all of these things end up being sort of more transient, fleeting things, which end up fine as just mutable state inside of your composable and owned by that composable. But I think that MvRx seems like a good option for having a place to hold and manage state updates that are more domain specific to your app, and like happen to be doing things across views and across the lifetime of a given screen or view or something like that, which I think is like the intent of MvRx. So I think it's not about which one scales. It's about what, like, using the right tool for the job in each case.
Yeah. And then for the next question around the scoping, and if your app doesn't use fragments, this is something Leland and I were talking about a little bit the other day, where this example is maybe a little bit simpler than the final implementation would be. But in the final implementation, there would be basically there would be a lifecycle owner ambient, and in fact, right now that is one of the default Android ambients is a lifecycle owner ambient. And in the Jetpack world, a lifecycle owner is just something that is created, started, stopped, or destroyed. I think pause and resume also in there. And these are totally decoupled from activities and fragments, and they're just like, has it been made yet? Is it visible to the user? Is it the primary thing the user is interacting with? And then the inverse of those states. And that's really all that you need to have a view model store. And so you can imagine an entirely composed world where you have navigation handled entirely by Compose. That navigation component inside of Compose would have to have some notion of when something is visible for the first time or destroyed. Like, it has some notion of a backstack, even if it's handled entirely in Compose. So as those internal Compose only navigation systems get built out, then there will probably be a lifecycle owner inherent to those navigational components, which could then become the scope of MvRx ViewModel Store, or really anything that uses lifecycles. So lifecycles, I don't think that they're inherent to fragments and activities, and they play pretty well here because they still serve a purpose.
Yeah.
Do you agree with that, Leland?
Yeah. I mean, I think basically you're echoing some of what I was saying the other day. So yeah, definitely.
Great. So one thing that I was thinking about when thinking about the API for MvRx is around recompositions and invalidations. So, and tell me if anything I'm saying is crazy, because I'm pretty new to the Compose world, but I imagine you'd only want to trigger recomposition in the minimal part of your composable tree. Is that correct?
Yeah.
Okay. So let's augment this example with one of the useful things in MvRx. So I'm going to add a body to this counter state, and I'm going to make an isEven property, count mod2 equals 0. So this is just a normal Kotlin data class. And if I make a property, it's immutable. And if I make a property in it, it's always going to be up to date, because anytime you change the state, you get a new instance of with the copy function, you get a new instance of this data class, and then these what we call derived properties in the body of a data class will be updated. So here we have an is even a property. What if, so let's say we had a really big state class and then only one thing on that state changed, and you could tie that down to one specific part of your tree. Maybe we change, instead of showing count, we just say is even colon state dot is even. Is there a way we could make it so that we're only invalidating our composable tree when is even changes instead of whenever all of the state changes?
I mean, you could, but it would. I mean, there are trade-offs here, right? So right now, the way that we handle invalidations is like based off the object instance. So when we read or write a value of a state object, so right here, this is where the state object gets read, and then this is where it gets written to. And when you read a state object, the current scope ends up getting like subscribing to that value
Right.
wholesale. Now, I mean, what you could do is you could make like is even. It could be its own state object that's just derived from this other state object, but. And so in that case, it would end up having its own subscriptions like independently.
Yeah.
But you're also introducing a lot of overhead for like if you did that automatically, right? For like every single property of a state object, then now all of a sudden, I mean, this like simple data class ends up being something that, you know, it has a lot of containers and it's managing a lot of different subscriptions, and so it's unclear. It's a trade-off. There are obviously cases where that would be valuable, or like that would be beneficial in terms of the performance profile, and then there are cases where it would not be, and so
Right.
It's sort of hard to say.
So, okay. Well, I want to walk through this potential addition though. So instead of mapping it to an actual different data class, lost your audio, I think. Okay. Instead of mapping it to a different data class, what if we map the state flow before that? So let's see. And
Yeah, I see what you're saying.
so then you never, if it's just one property, let's see, BSS, something like that. Okay. So then
Where are you right now? I can't. Didn't we find there's like a way I could like follow you? Oh, it's up here, I think.
Yeah. You click the G.
There we go. Okay. Now I'm following you. While you're doing that, I'm going to read some of the chat. The studio looks blurred. I can make the windows smaller, maybe. I am using OBS. So, yeah. So thank you, Chuck. Chuck Jazz D, by the way, is a colleague. He's helping out on the chat here. He knows more than I do about all these things. Does every read to the state has its own subscription? And if so, is it update when the whole state update or when the red part is update? So right now, like mutable state has a single value property, and that property has a type, like it's a value of some type. And all we know is when the value changes. So there's no like individual understanding of the properties of that type. But you can actually, so this is something kind of interesting. If you look at mutable state of, oh, I need to unfollow you here. So if you look at mutable state of, we actually have a policy class, which is this snapshot mutation policy. And so it defaults to structural equality, which basically means that to determine if the value is changed, we're going to call dot equals on it. But you can do other things here. So this is just whether or not those are equivalent. So here's basically where we would end up calling dot equals. But you could, if you were only interested in a specific property changing, then you could specify that mutation policy there. And that would, by providing like an equivalent, but that just checks that property. And that would do that for you.
Yeah. I guess you'd want to be careful with that, right? If you had a larger class and then you set your structural mutation to only check for what you think you need at point A in time, and then in the future you start using another part of that object, you might wind up in a situation where it's not getting recomposed when that other property changes, right?
Right.
So I've updated the example now. So I've added the ability, an optional mapper. So we could map our state to another type or substate. In this case, the is-even derived property that I added. So presumably here, it would only recompose every other time the state changes. Is that right?
Yes, because the value of the state property now is just is-even instead of the count. And so, yeah. That would update it appropriately.
Now, let's say you're using something that you knew had distinct until changed, like a state flow, or just some other property that you know of. Would you want to change that? The structural or the
mutation policy,
mutation policy to be a referential equality instead of structural?
It depends. I mean, it depends on the type, probably, right? I mean, so yeah, if you had if like you were using flow to do the diffing for you, essentially with distinct until changed, then you might know for sure that the only time that value is going to update is when it's actually changed. And so then you can basically tell compose like don't bother calling dot equals because I know that flow's already done it for me. Yeah, that would make sense. Yeah.
Probably want to do that here actually for MvRx, because MvRx only emits unique states. It internally does distinct until changed. However, unless you've added a mapper, in which case that's no longer true.
Right. Yeah, so it makes sense to do that here. And then, so I guess you want people to use data classes for state, so they get copy, and so these will all have equals implemented on them.
Yeah, that's correct. MvRx enforces that.
Oh, gotcha. Okay. Yeah, this is pretty slick. So do we want to, what would happen if we introduced some like asynchrony into this? So like if increment count, like let's say we, I wanted to do like increment count, at some point. and it'll just do that at some point in the future. How would I do that?
I mean, you may just add an artificial delay with coroutines.
Okay, and so here I can, but what coroutine scope is that gonna get?
It has view model scope.
Okay. Okay.
It's similar to Jetpack Compose. Unless, so I mean, we could talk about that if there's maybe you want to use a composable scope or something. But so MvRx view models are going to have a coroutine scope built into them already from that's tied to its own creation and destruction from those view model providers.
Yeah.
It's very similar to Jetpack view models.
Yeah, it
So
makes
here
sense. I didn't know that you had the scope here. I guess I should have thought about that, but
we should do another thing to demonstrate some composable stuff. What is it complaining about?
here I can import it.
Oh, it wasn't even read on my side. Okay.
So should we run this? Will this
Yeah.
work? Yeah. All right, let's try it out.
We're gonna have to switch back from counter to counter.
Oh, right. Okay. I feel bad every time I hit run. It's probably like destroying the stream quality. Oh man. So Tonal uses Flutter, right? But not for everything, just the companion app, right?
That's right. So the tonal hardware is all native Android, and we have a companion app on Android and iOS that is Flutter.
Have you tried to take any of the MvRx ideas into Flutter at all? I mean, you use MvRx at Tonal, right?
Oh yeah, everything is MvRx at Tonal. So I mean, Flutter is so it's a good question. We haven't built something like MvRx for Flutter. We've gotten by mostly with using an ambient like structure. We use the package called providers that is it's from the Flutter community. It's a pretty good package, and it definitely resembles ambience in terms of its functionality. And I mean, I would say that I'm not sure how well it would scale to something of the complexity of Tonal. It's not a small app. It's about 50 or 60,000 lines of code, but each individual screen is relatively simple, in which it's displaying a few API calls in some sort of a fancy UI. So I think if it were to become enormous and really complex, like say the workout experience in Tonal, then we'd be looking for something more. And I'm not sure what the best the Flutter community has there is. But it's interesting, like when you do, like that's maybe something worth talking about. When you build an app from scratch with something that resembles Compose, and to be clear, Flutter architecturally is very similar to Compose from a structural perspective. You just wind up structuring things so fundamentally differently. It'll be interesting to see whether things like view models and MvRx do stand the test of time. Even if they work great, we may find that we don't even need them anymore. I don't know.
Yeah, I mean, so that's like one of the things that I'm trying to play around in the back of my head is like, is the like view model state kind of pair that MvRx creates versus just having a view model directly, is that like what all value is that giving us in a Compose world? And it, like, as I'm looking at it, like I feel like there is some, I just can't articulate what it is.
Yeah, it gives you one place where you know that your state changes. And so that being said, if the whole tree of composables is truly reactive on like perfectly reactive on those state classes, the situation you really want to avoid is that happens with traditional views in a is it imperative way? Is that the right one? With fragments is I think your favorite word is imperative and declarative. Um, you have a fragment, and then you wind up pre-MvRx with normal view models, subscribing to a bunch of individual state properties, and then making view mutations in each one. So you could imagine you had like, let's say you had profile loading and stats loading, two different network requests. You might, the UI might want to show loading if either of them are loading. And so someone might come in and they'll just subscribe to the profile loader, and then anytime it changes, they'll update all the profile views and then set the loading status based on the profile live data or flow, and then later you add stats. Well, you end up in a weird situation where then in stats you have to check the profile. You have to remember to check the profile state in order to show the loading indicator, and then update all the stats views, or you like combine stats and profile into some sort of a combined or transform flow, and then you update stats and profile in the same place. But then what happens if you got a third thing? And then you wind up with this complex thing where whether or not the loading indicator is shown is actually a function of the order that all of the events happened in order to get to that point. But it might be less likely to happen with compose.
Yeah, I think it would be. I mean, I think what you're describing can still happen. It's a side effect, I guess, of you making something stateful when in reality it's actually a projection of other states. And so I think that this would be much easier in compose because the loading itself might not be a state value. It's just a Boolean that is calculated based on the actual state. And then I think that you can kind of avoid the situations you're talking about there.
I'm going to pause you for 1 second. I sent you a command that you can run that will tell you if your MacBook is throttling, because I suspect it is throttling very heavily right now. From the command I sent you in Meet, it'll give you a CPU speed limit. I bet you're at.
Can you send it to me in Slack instead?
Sure.
Yeah.
It sounds like the audio is still all right. I'll ask everyone on the stream to just make sure to let us know if things get out of hand.
Yeah, it seems like this job I got the same result. I have my computer. Interesting. I mean, it's unclear to me if a capture card would fix this problem for me, unless you're talking about me having a separate streaming PC, which certainly would solve the problem. But yeah, yesterday seemed to go fine. Let me run this command. No thermal warning level has been recorded. No performance warning level has been recorded.
CPU speed limit's 100?
Yeah, I'm at 92 right now. The scheduler limit's 100.
All right.
Oh, no. No, CPU speed limit's at 30.
Yep. There you go.
What does that mean?
Your CPU is at 30% of its maximum clock speed.
Okay. Is there some way for me to change that?
Ice, a bucket of water, big fan.
All right. Well, I don't think I'm going to be able to tweak anything right now.
If it was fine yesterday and it's now, it seems to have gotten progressively slower. I switched to a desktop because I've had a lot of issues with MacBook throttling. If you follow me on Twitter, you may have noticed.
It says right now it's fine. Yeah, I am using OBS.
Okay, we can move on since the audio is fine. I don't want to waste people's time. We'll figure this out later.
Yeah. We could shift into to interview mode instead or something. So hearing some of your thoughts on domain state modeling. Should everything that is rendered on screen be modeled in the state, assuming it should update? What about individual components that might only care about slices of that state? So I mean, this is kind of what Gabe was talking about, where you could, if you just care about a slice of the state. So like in this example, if for some reason in our counter we only wanted to know if the count was even or not what the actual count was, then you could do something like this, where you basically map the whole state, the counter state, into the projection that you care about, which in this case is just a Boolean. And then you could even you can even do the calculation there directly if you wanted to. But that is sort of accomplishing what you're asking, is where this would then only, it would only recompose when is even changes instead of when anything in the state changes. So that would be one way to do it. Hi, Sam. Good to see you.
I'm going to try something here. It's totally for the sake of a demonstration, but I think it could represent something useful. So someone was asking about one-time events. I think animations is also something that people are curious about. So what if we just had like the top padding of the text animate down smoothly every time it increments?
Okay. Do you want to code that, or do you want me to code that?
You lead. There's a bit of lag on my side anyway.
Okay.
I think it'll be better.
Okay, so let's just do this, right? And is that going to be enough for me?
Just remove the third.
Yeah. So now I've got the state object, and so Gabe said we want to animate the padding here. So let me just count is count.value. So I'm gonna blow some people's minds here in just a second. So this is one of my favorite things about Compose, but so let's just say we now want an offset, right? For so like text padding, or like text top padding. And let's just say that we're gonna create a padding that's a function of the count. So state.count, times 10. So 10 dp for every count. Right? And I need to switch the argument order here because I want to take advantage of the operator. All right, so now we've got our text top padding. And here, state.
It's interesting, the operator was only written one direction. Is there a reason for that?
We could define the inverse, but we just hadn't, and I happened to have run into that before, so I knew the problem.
There's not an explicit reason why it wasn't made.
No. Oh, I got my count value wrong. Okay, so then up top here, for instance, I can say top is text top padding, right? And so this now modifier. All right.
Yeah. Anyway.
What were you gonna say?
The IDE seems to really want to import fold in and fold out when you start typing modifier.
Oh, I know. I really don't like that. I don't know why it does that. But okay, so we're gonna run this, and so I haven't done anything animation related. As soon as I start typing, yeah, okay. So it must be related to this code with me thing, which Kind of makes sense. It's feedback I'll give JetBrains, I guess.
If you want to switch to the IDE, I can go ahead and close mine. I can follow you on Meet, and we can talk about it because you'll be doing most of the typing anyway.
Okay, yeah, we can do that.
Okay.
So, oh, do I have to do something? No one joined.
I exited on my side. If you want to just open it up in Android Studio.
I'll just keep it here because I got to set it up. But okay, so now we've got this thing, and I'm still using the delayed version. So when I click, it'll wait 2 seconds, and then it'll move it, right? So here I go, and there it moves. So there's no animation here, but all I need to do is wrap this with a call to animate. And I'm done. And now it'll animate, which I just personally think is super cool.
This is great. I love that we picked an animation when your screen is half a frame per second.
Oh yeah, we'll see how that goes.
The people on Twitch, you're going to have to take our word for us that it did in fact animate.
Okay, so now I'm pressing it a few times, and you can see that it's now animating instead of going aggressively down. I can change it to be 100 to make it a little more obvious.
So this animate seems like magic. What's going on here?
Yeah. So
I think you just collectively blew a bunch of people's minds all at once with one word.
Yeah, so this was not planned, by the way. Gabe just asked a really good question that I happen to know a fun answer to. But so one of the ways I like to describe this is that composable functions abstract over time. So a composable, you have one definition for a composable function, and it describes what your UI looks like across all time. So this text top padding is, I'm not describing like what each individual value is each time. I'm not saying it's 100 and then it's 200. I'm not saying it's, the current plus that. What I'm saying is that whatever state.count is, it's that times 100 dp. And that is like semantically what the value is pinned to. And that's independent of time. And so what happens when we kind of remove time from like the notion of this function is that we can start to play around with the idea of like what a declarative animation API would look like. And so we can say this value is 100 dp times the count, but it's animated. And what that then means is that whenever it changes, the value that I want is this transition between the input values. And that's just what it is. I don't have to describe, any of the in between. It's sort of done for us. And so the way that this works basically is that, composable functions have the previous value. So we know that this is like how all of Compose works. When you just say, okay, this is the UI I want, you don't have to say, okay, the old UI was this, so now tweak it this way so that it's this new UI. All you have to give it is the new UI that you want. And the runtime is able to figure those things out. And the way it does that is by having access to the history. And so animate then just says, okay, whatever the previous value was, we're just going to animate it to the new one.
There's a question. What is the type of animate?
So what animate, this happens to be an overload of animate, but basically it has the same type signature as identity. So whatever you pass in is the type that you get out. And so that's the really cool thing is like, this can, I don't have to overload my type system with with like any new like animated DP values or anything like that. And so like I could put just animate right here, and that's sort of the point, is that the overload of padding is the same one that we were using when it was a constant.
So how much are you going to miss transition manager begin delay transition? A lot.
I'm okay leaving it behind.
This is magic. This is really awesome, and it seems like a lot of people are excited about it. One of the things that, as coming from someone who's done a lot of Android animations, that we always have to be really careful about is pre versus post layout animations. So some things like transition or translation and scale are done after layout. So if you animate them, they're just new drawing commands, super fast, easy to hit 60 FPS. But other things like changing layout params that trigger relayouts, trigger the whole screen to relayout and are really hard to hit good performance with. Is there an equivalent with Compose, or are there considerations you need to think about when doing things like animating padding, sizes, position, etc.?
Yeah, there is. But first, let me answer a few of these questions. Well, I guess someone asked, how do you choose interpolators, and is it just tweening? So it's not just tweening in the sense that you're probably thinking. I mean, so it's physics-based animation. So by default, it uses a spring-based physics to transition between values. But you're able to pass in your own animation spec if you want to do something else, like just a linear interpolation or something like that. So that's sort of how that works. I just wanted to answer that. So you can pass in a second parameter here if you want to do things. And another like thing that I just kind of want to point out is like this is really nice to basically drive an animation and get multiple like you can have multiple coordinated things happening at the same time, but all driven based on one animation. So let's just say we have like animated count here. And so what this now represents is like, well, this probably won't be, well, it won't be good because it's just animating and because it's returning in it. But like, so
to float.
Yeah, so let's just do that. So now I've got like an animated count that's a float, and I can calculate other things based on it. So animated count. So I can do that, but I can also like do another thing. So let's see, what's another like scale or something, right? So text scale. This is gonna be, let's say I did 100. So yeah. So let's just say 1 plus animated count divided by 4, right?
I'm gonna pop back on code with me because I don't think it made it any better when I hopped off.
Oh, really?
Maybe.
So then now I'm like animating two things just based on this count. I'm animating this top padding and also the scale of the text. And so in here I can say, I need to end up using this, which I can then say scale, text scale. Let me clean up some of this a little bit.
While he's coding this up, if anyone on Twitch wants to see anything specific while we're on this example or something similar, feel free to just throw it in the comments.
So anyway, I'll go ahead and build that real quick. But to answer your original question, which is like, what kind of considerations do we need to have for this type of animation? Like if it affects layout or not, or if it's drawing only. And compose like will allow, like you can kind of animate in any of these different phases, and you can sometimes end up in a better position if you like just caused a draw to happen as a result of the animation. But also like layout in compose happens much faster than with views. Some other things might happen slower. Like with compose, you have to worry about composition time in addition to like layout time and things like that. Can you preview animations like motion layout? We're working on my two webcams at once. I don't, would the two webcams at once affect anything as far as the stream speed? Because I'm only... Oh,
anything that's using your CPU right now, it's just throttling really badly.
Okay, let's see the example real quick. I guess it ended up building. So if we do this, so now it's scaling as it increases. Anyway, that's the example. But if like basically the layout and draw phases of compose, they participate in a similar kind of invalidation scope system that composable functions themselves do. So if you end up reading a state value in, for instance, like a draw lambda, so like I can use this draw behind modifier, and then like if I you know, to draw rect color dot blue, and then if one of the positions or something was based off of state.count, and I read state.count inside of this draw behind lambda, then this composable function wouldn't be subscribed to state, only this draw lambda would be, if that makes sense. And so then that would
you can actually differentiate between the two.
Yeah. So like if just something that's used in draw gets invalidated, then we'll just redraw. We won't bother recomposing.
I see. So it looks like two of the modifiers here are prefixed with draw. Is this a general convention that can be relied upon to know whether it affects drawing or recomposition?
Maybe. So actually this might get renamed, but this one, it won't get renamed. This one's correct. We used to be a little more heavy on the draw prefix, but we're kind of moving away from it. So
is that going to make it harder to understand what the performance implications are?
It could. Like I think that's a valid concern. Our sort of hope is that for the most part things are just fast enough. But yeah, I mean that's a concern. It's something that we're balancing, or we're trying to balance with, like, you know, trying to be clear that like something is drawing related, like that. I don't think that that's like really hidden anywhere, but there are subtleties in the way this works, and just that you know, a read of something up here might be different than a read of something down there in terms of its performance profile. And so I think that what we really want to do is try to do a really good job exposing tooling to people to help them understand what's happening if they're seeing more recompositions than they're expecting or something like that.
Have you seen the rainbow boundary flutter dev tool?
I don't think so. Well, yeah, actually, I think this is this is similar. There's like Rainbow CSS extensions. This basically just colors different view bounds with like different colors. Is that?
Yeah, and every time it rebuilds, it increments a color wheel. So then you can see if something is like constantly invalidating or rebuilding, you just see the color on the bounds starts to rotate around the rainbow.
Oh yeah, okay. Yeah, that makes sense. Yeah, I think we've talked about similar things, not implemented exactly like that, but ways to visualize what's recomposing and stuff like that in the IDE.
The draw layer naming is interesting. So in the canvas world, there's the notion of save layer.
Yeah.
And the save layer call, for those of you who aren't familiar, moves all of the subsequent drawing commands allocates and then moves them to an off-screen buffer, which can then be drawn back or composited back to the main canvas with the restore call. And it's interesting because it's a very expensive call. It has to allocate and then compose back this off-screen layer. Whereas here, draw layer, it looks like it's manipulating things like scale, like a post drawing or how it's drawn, not allocating a new layer.
Yeah, so my understanding is that draw layer here will cause text to have its own render node. That's my current understanding. If someone's on the stream that knows better than me, they can let me know. But I think that that's true. But yeah, we were just talking about renaming this. I'm not sure if we came to a conclusion or not.
I like this question from Zach Hughes. That's something only you can answer, Leland.
So can you clarify the question? Are you saying that we managed to make the compiler in a short amount of time, or are you saying that the code that the compiler produces is fast?
I want to give you credit and say both.
I don't know if we made it that quickly.
I feel like we were just working together at Airbnb yesterday, and here you are. You've built large lots of Jetpack components in the meantime.
It's been a while. I'm gonna turn my lights up here. My camera's pretty dark at the moment. Zach, I don't know if you heard me, but both. Okay, well, I answer independently. How did we make it quickly? I mean, I don't think we did. I think we took a long time. And I think that there are a lot of difficulties along the way that made it take maybe longer than some people would guess. One of the things that was difficult is we were building on top of the IR backend for Kotlin, and so we were doing this while JetBrains was building the IR backend. And so at times it kind of felt like we were building a castle on top of quicksand, and like it was just, or rather maybe a house of cards on top of quicksand. But it just sort of felt like whenever there was an issue, there was like multiple layers of the stack that weren't robust, and so it was really difficult to. I mean, that just creates a difficult situation. Like when something happens, you're like, okay, is that because the implementation of text is wrong, or is that because the compose compiler is reading text and compiling it wrong, or is that because the compose compiler is using the IR backend of the Kotlin compiler and that's wrong? And it's just like, it was a lot, but it was the right choice for us to target the IR backend because it's much easier to build something as sophisticated as the compose compiler separate from JetBrains on top of something like an intermediate representation. But
why was having the new Kotlin IR backend so important for Compose?
Well, that's what I'm saying is that, the previous backend, if you were to try and implement something that like tweaked the code generation, um, it would be very difficult for that to live outside of the Kotlin repository because everything was so intertwined together. Um, Whereas with the IR backend, we're able to have our compiler just be an IR to IR transform. And so they target a representation that their backend then generates code from. And we hand Kotlin the same exact representation. We just transform it. And so that gave us like a natural point to plug into the Kotlin compiler in a way that wasn't going to be like a maintenance nightmare. So the other question, which is how did we make the code that the compiler generates so fast? I mean, ultimately, it's been a lot of iteration, and hopefully there's still a lot more left. But I mean, there's kind of two parts of it: is like making the code that we generate better, but then also making the runtime, which is like what the code targets, making that better and faster as well. And so it's sort of like a two-pronged effort. And Chuck Jazz D on the stream here, he's responsible for a lot of the performance work that's been done on the runtime itself. So yeah, hopefully that answers your question. I appreciate that you think we did things quickly, but I'm not so sure that that our management chain agrees. It's been a long project. Google doesn't do projects of that like time scale that often. We basically, I mean, we haven't shipped a 1.0 yet, and we've been working on it like basically 3 years now. So that's not typical for Google, and I think it's really cool that we were able to make to take the time to build something of that like scale and investment, and take the time to do it right, or what we thought was right. So.
Yeah, and I've heard a lot of positives from the community, people who've used everything from React, SwiftUI, Flutter, and Compose, and Compose really was able to take a lot of the best aspects of other functional component UI paradigms and really build something that feels really modern. And I'm looking forward to seeing this in really large apps. I know at Tonal we're really excited to use Compose in production, and we also want to understand what that migration path looks like, because it might look really different in a greenfield app, as well as some of the larger apps like the Tonal, Airbnb, Twitters of the world.
Yeah. So what is, yeah, it would definitely look different, but I think the migration path is pretty sane. For the most part, it can work in both directions. So you can instantiate a Compose hierarchy anywhere you have a view, and it can be at any level. And inside of a Compose hierarchy, you can sort of start a view hierarchy, and so you can like inflate a layout or add a view or something like that. And so it's pretty sane, and like honestly, like if you're coming from like the migration path, which I know both of us are, of something like React Native, where you have a whole separate memory space, right? It's like a different realm. I mean, not only is it a different language, it's a different virtual machine that's running on device. And so piping information across those things is really difficult. I mean, you basically end up with two completely separate worlds, and any communication between them needs to be done carefully. Whereas with Compose, I mean, this is all just Kotlin JVM, so any of the existing classes and types and everything that you've been using, and utility functions and data repositories and all that stuff. Like it'll work just fine. And that would be if you are comparing the migration path to something like React Native or something, that would be one thing that would make it significantly easier.
Yeah, and Sam, to answer your question, on the companion app, Tonal, we probably would have Flutter for the same reason that people choose cross-platform frameworks, and Compose, as we know, is not that today. But it's Compose exists for the reason that native Android still exists and will continue to exist for a long time. I'm not on the Google team, and who knows, maybe Compose will be on multiple platforms someday. I'm not going to force your hand on that one today, but who knows? It's not technically impossible at some point in the future, but who knows? I want to go back to this example, actually. Maybe talk about another like philosophical, like how to think about structuring your composables. Here, where we have the view model, we have one option here where we get the view model from within your composable. And then this feels kind of like like a direct translation of how we were getting the view model from a fragment. But two other options that I was playing around with when thinking about how to integrate MvRx with Compose is using ambience, where you either provide the state via an ambient, or you provide a state flow via an ambient. And any thoughts?
My initial reaction is a bit negative. I mean, I think that the things that you're providing are very intrinsic to the composables that you're going to be writing. And I don't like the idea of using an ambient to pass that through. I think that those should be looked at as explicit dependencies, and so my initial reaction is I would try to avoid putting something like a view model or a state object, and I'm using state here as like a MvRx state object, although it's true also for, well, maybe. But anyway, I would avoid putting those in ambience myself. I think that a lot of people, they like start working in these types of frameworks, and then they start to pass all the, like they have all this data that they pass around as props into like or parameters, like into multiple levels, and they like, I don't know, they get really bothered by it, and then they start to try and find a way to like avoid passing the parameters, and they might find ambience, and so they're like, oh well, I'll just put that in there, and I think embrace the parameters to an extent. You're indicating the explicit dependency of your composable, and you want to think of it as like, okay, I receive this data as input, and I'm then displaying it. And if you find yourself like passing these props through multiple levels, I would recommend, there's a section in the Thinking and Compose talk that I gave that kind of talks about this, but like one of the things people don't realize is that you can do, like the way column is able to be written in this syntax, that is not something unique to composables that like we write at Google. Like you can do that too. And so, I can just do something like content, and maybe this is like, I call this here, and this is a way to basically give your parent control to put anything they want at this location, and that is often what you want, and is like an important way to make your composables reusable and composable. And so
is this like the render prop of the React world?
Yeah, it's exactly what it is. And so then here, like just to explain what would be happening here is like, um, you know, this would be a way to have counter have this like content prop. And the important thing to realize is that like I can have you know, some variable here, and I can have like multiple levels of nesting, and like I passed foo all, you know, all the way down this like 3 levels down the hierarchy, but counter doesn't have to know anything about foo. I didn't pass counter a foo parameter. I passed it a content parameter that captured foo. And
So it's one of those cases where back before where you were reading a state variable, but only accessing it within your draw behind modifier. In this case, if you had a state variable foo, and then you only accessed it deep in your tree, would it only invalidate, recompose that text part of your tree, and not, it wouldn't recompose the outer counter, even though the lexically foo is accessed above it?
Yes. So like for instance here, let's look at this counter 2 example. I'm reading count here, and that means that when count changes, it will actually only invalidate this. So it'll only invalidate the inside of the button. It won't invalidate all of counter 2. Because it happens to just be read down here. And so yes, so that's how that works.
That's really interesting. It's definitely, that feels like one of those things that is really, well, probably shouldn't matter to most people if compose and phones get fast enough, but is something that's just good to know. It's just in terms of how you think about the way composables work and some of the magic that's going on under the hood. I both want people to understand that, and also want people to never have to care about it.
No, I struggle with that all the time. It's like there are all these things where I'm like, okay, do I want this person to actually know what's going on, or do I want to tell them just like, well, just don't worry about it. And it depends. I mean, I think like what you really want is you want to teach someone to have a good intuition for things, but like also to not care too much until it's actually a problem. So like you give them the tools to make something better if they need to, but like embrace just the fact that I can just write this like very naturally. Like instead of thinking about where I use count, like if I decide that, you know, it's useful for me to, you know, to save this as a you know, a temporary variable, and I want to put it at the top of the function, like just go ahead and do that. Like just don't worry about it too much. And if a problem happens, you know, then you can start, like hopefully we do a good enough job providing the tools to help you understand this better. But yeah, like I have a fear of people like kind of thinking so hard about this that they're just like paralyzed. They like can't write a line of code because there's too many new things to think about, and that's like honestly like a really big concern of mine.
Yeah, I feel like you get this interesting opportunity to be a little bit of a fortune teller in this scenario, because you, for those of you who don't know, were very, very deeply involved with the React community prior to joining Android. And they've been working in this pattern since 2014, 2015 era, somewhere in that time frame. And
2013 when it was released publicly, and then they had been using it for a little while before then. But yeah.
Right. Yeah. And there have been these waves, I feel like, where the community tries to figure out these patterns together. And early on, some of these, one of the biggest conversations from my memory was around business logic, business components versus presentation components. And some of these patterns arise where, okay, if you have a MvRx view model and a composable, well, that's kind of a business component, right? It needs to understand, it needs a view model owner, a view model store. It needs all this stuff, and then it composes some stuff. And wouldn't it be nice to just have another composable that just takes that like really pretty mutable state class and renders it? And it maybe you can walk through with some of the life cycle of that conversation in the React community and how it would apply to this.
Well, the post that I think you're talking about here is like smart versus dumb components. This was written by Dan Abramov. Yeah, okay. Actually, I guess he called it presentational and container, but this became the term that people used. Smart versus dumb, which he says I think is one of the things he regretted. But before I show this, I'm guessing that most of the people on this stream probably know who Dan Abramov is, because he's just an amazing human being. But if you don't, he's one of the current core team members of React, and he's very popular in the community, and he created Redux, which a lot of people are familiar with, and he has a really good mind for these things. But so one of the things he wrote early on was this article, and I think that honestly, I think that the article was a little bit reactionary. I think that he wrote it to quell some of the concerns that the community had at large, which was all around this whole like separation of concerns thing, and like this fear that like, oh, I'm putting this logic in my UI and I'm mixing it with view logic, and should I be doing this? Like, is this a bad thing? And so I think this article is written basically to quell those concerns a little bit. And so this is my opinion here. You can ask Dan if this is accurate or not, but I think that's a little bit where this article is coming from. And I think the problem is when you're as popular as Dan and you say something, everyone listens, like everyone. And so this like immediately just became this dogma around the whole community. And I think that's when you start getting into trouble, is when people start, they stop seeing the gray area in all of these things. But anyway, so he's actually updated this article. I wrote this article and my views have since evolved. In particular, I don't suggest splitting your components like this anymore. If you find it natural in your code base, this pattern can be handy. But I've seen it enforced without any necessity and with almost dogmatic fervor. I haven't read this in a while, actually. So I think it's funny that he used the word dogmatic here far too many times. The main reason I found it useful is because it let me separate complex stateful logic from other aspects of the component. Hooks lets me do the same thing without an arbitrary division. So this update came after hooks came about. And like, honestly, I don't know. I sometimes I struggle to find the right answer here, because the answer that I want to tell people is just do what feels right, but that's not an answer that people are looking for. And it's not really like a helpful answer, but sometimes it's like it kind of is the right answer though. But like to kind of dig in further is like one of the things I try to think about a lot with like the design of Compose, and that we've thought about a lot since like the beginning, is how easy it is to refactor things and move things around. And I think one of the problems is that when you start with this separation, sometimes like it can end up creating a lot of like early abstractions that are the wrong ones. that people end up choosing to like, because they feel like doing the thing that they want to do is breaking this dogma. And so what, like, I guess I would try to push people to just kind of like, to just build things and like realize that these are just functions, and refactoring functions and splitting them apart and moving things around is like one of the easiest things that you can do. It's like it's way easier than classes, by the way. This is one of the reasons I love functions and I love this design. Like one of the real cool things here with Compose, and this is true of like React and other things as well, but is that like if something weird is happening, there's this cool power that I have inside of a composable function, which is like any sort of interior that I have here, like inside column here. I've just selected everything inside of column. I can just do that, and I can just block out like everything that's in column, and this is like,
you're still in Chrome, by the way.
Oh, sorry. Thanks. I'm really bad at this. I'm gonna have to get better. So basically my point is that when you're inside column here, you, like if something weird's going on here, it's incredibly liberating to be able to just do that. And there's almost no code patterns that will cause that to be an uncompilable state. And that's like a really valuable thing. And I mean, you know, I can have parameters up here that like are referenced down here, but like the fact that I can like do this and use like IntelliJ's refactor tools and stuff like that is incredibly valuable. And so I guess I'm deviating from the underlying question here, but I want people to, I know that this is going to happen, and like this is going to be what people want to do initially in the Compose world, and I think that's okay, but I want people to not be dogmatic about it, and to realize that there's a gray area, and to realize that Compose was designed in a way that it's easy to back out of like this thing. Like if I put, you know, some, you know, val foo equals, you know, and then I type some expression here, which is like some heavy business logic. It's pretty easy to move that out. Like, you know, for one, I can just say, I can turn it into a function, you know, and now that's like you know, with inputs, and now that's like a testable, that's a testable piece of my code now, you know, separate from the view, and I can move this into some other class if I want to. I can move everything below here, you know, counter UI, and I can pass foo in there along with state, and then I can you know, then I can create this separate composable here, you know, this is the presentational component in Dan's post, right? And I can just move all that there, and like that was super easy to do. And so my point is that it's easy to move in and out of this pattern, and so to like avoid the dogma of it, I guess, is what I think would save the Android community a lot of time in the long run.
Yeah, I think it'll be fun, and it's for the community to stay engaged, and maybe I hope we can learn and fast forward through some of the conversations that some of the other frameworks have had.
By the way, I see Spike in the chat. Good to see you, Spike.
Oh, wow. Pressure's on now.
OG React Native crew. Come on.
They're all here. Okay, so I do have a question. So one thing that tripped me up a little bit, and I think I'm starting to get it, but you can help clarify it for me and others. So let's talk about this heavy business logic function. I've seen a number of compose samples in which you call a function that's not a composable that's part of your UI, but it's annotated with composable and just called like a function and returns some value. Why might you want to do that?
I guess the answer might depend. Heavy business logic. So do you mean like something like this?
Yeah, returns an int or something, and it would not be part of your rendered tree.
So this is I talked about this on the stream yesterday, but this is like what some people might refer to as an effect, colloquially inside the compose team. I don't think that term is necessary anymore, but basically, this is kind of equivalent to React's hooks, but it's also it's a bit more than that, I guess. But anyway, so when you're inside a composable, you have some extra capabilities. So like one like fundamental capability is that you can call remember, and so and maybe I could say a more broad statement is that one capability is that you can call other composable functions, because you can only do that from a composable function. But remember is sort of the fundamental bit. So remember gives you access to history, right? It lets you save something for the next time it's called at that position in the call graph, things like that. The other thing is I can grab a current ambient, which this can end up being powerful sometimes. So like maybe this business logic needs to grab some ambience in order to do like its thing. And so if you only wanted to, like, so that might be more convenient than saying like, okay, well, I like pass in foo ambient then as a parameter. Like you could do that, and then it doesn't need to be a composable in that case. And so maybe that's something you want to do. It depends on various things, but these are kind of the like some of the main reasons you want to do that. And like so like remember, and like you have access to other things as well, like you have on commit and some of the life cycles and stuff like that. Some people are in the chat. Let me make sure that we see some of their questions. What happens if you return value or state from composable? Well, I guess we just kind of showed that. So you can do that. It is a thing. So Zach used an ambient. We actually tried to explicitly define it earlier in the stream, but basically you can think of it as like a value that's like implicit in the scope where the composable is called. And so you can grab various things like context is one of the things that you can grab, because context will always be present in the composition. You can get like the current density, for instance. There's some things like that we provide, but you can also define your own. So Yassine says, you have to understand some teams don't have resources, time to experiment and look to be productive from day one. That's why they're looking for strong guidance. Yeah, totally. I mean, I guess the thing is I'm not against strong guidance. I'm just against the strong incorrect guidance. Which that's a snarky way to say it, but like
just do it right.
But like I think that we can give strong guidance when we know that like, oh, this is a known pattern that is like guaranteed to save people pain and like stuff like that. And to be honest, I think that giving people this presentation versus container components guidance will make them less productive early on because they'll be so worried about whether or not they're doing something the right way. And so I'm all for giving guidance, but I think that we should make sure that we know it's the right guidance before giving it. And sometimes that's hard because Compose is new, and we might have some prior context to like other frameworks and ecosystems like React and Flutter and stuff like that. But React is primarily used on the web, and the web doesn't have the same concerns that mobile devices do. Like the web is kind of, they're like writing a website. It's so easy to like just throw stuff on the floor because like the user just browses away and they don't expect anything to be kept. And like there's a much different user expectation for the web than for mobile devices. And so definitely there's going to be some different guidance based on state management as a result of that. But I don't know. I think we should be careful.
Can I say something to potentially the worst possible audience, but you can agree or disagree with it as well. Whereas the existing Android architecture and view system is definitely old at this point. It was designed in like 2005, but with the legacy comes a lot of guidance and frameworks and libraries and ways to do things and ways to search. And if you are working on a project or are in a situation where you really want that guidance, it is okay to just use what's been working for the community for over a decade now. And then because there is that incremental adoptability path for Compose, you can just adopt Compose later and don't have to feel the pressure to use it just because it's the newer thing. Because yeah, it's going to take some time to figure out some of these things. It's going to take some time to figure out what the best pattern for navigation and dependency injection is. And that's okay. Did I piss you off?
Are you asking me or are you asking the audience?
I'm asking you, but anyone.
No, I think that's fine. Yeah, I agree. I mean, one of the things that I think is interesting is that the Android community in its years of evolution has really started to go towards state management techniques that work much better with Compose than they do with the view system. So like this recent trend towards MVI and MvRx, these are great examples of things that work on the same principles that Compose does. And so we might have to do live streams like this to like figure out how to get them talking to each other. But at the end of the day, the fundamentals are more cohesive than they are using it with the view framework. Like the fact that MvRx pushes you to make everything immutable and to work with these immutable state objects, that's like incredibly useful for Compose. That works really well for Compose. Is this MvRx Compose extension already published on GitHub? Well, here, let me hit git publish. No, git push.
I got it. I put it just in already.
Yeah. So what is do you have anything to say about any plans or anything around MvRx and Compose? Like, would we end up seeing something like this in a MvRx release or something at some point?
Yeah, definitely. I think there's no question that we want to figure out what is the ideal interaction look like between MvRx and Compose. I was genuinely excited for this call just so we could talk through that and figure out what that might look like, because I think that they can live together in a greenfield project. And I also think that it's going to be critical for the incremental adoption for all the companies that are using MvRx, including Tonal, Airbnb, Dropbox, among many others that are successfully using it today. So yes, I would expect a MvRx Compose artifact to come out almost certainly before 1.0, but ideally as soon as we feel confident that we figured out the right way to do it.
Yeah, I mean the ability to reuse, like if you were using MvRx right now very heavily, the ability to just have all of these state and view model objects just immediately be usable from the UI. Like you would end up just rewriting, like if you're using epoxy or whatever, like it would just it would just be and epoxy ends up being really similar anyway. You just like put some uppercases somewhere.
Oh yeah, the incremental adoption coming from the MvRx and epoxy world I could not imagine a smoother glide path between the two. It's almost perfectly the same.
Yeah. So yeah, that's exciting.
So, this is exciting. Any other questions? Anything else we should touch on today?
Yeah, we are. Well, we started late, but yeah, we're a little bit over 2 hours now. So, Joe, NRB, Joe, it's good to see you again. From yesterday, apparently, I think Joe NRB works at Twitch, and I'm just curious if there's anything I could be doing better other than just getting a new computer. But I guess I don't want to start just seeking consulting tips from our audience here. Any thoughts on what kind of iteration times we might see with the app preview someday? I've been curious. Fully incremental and similar as we get undefined and underlined in almost real time. Yeah, I mean, so definitely its current state is not where I want it to end up. It's way too slow right now, and there's a lot of reasons for that, and some of them. Gabe's cam is out. Yeah, that's my fault. I need to fix that for the next one. But yeah, there are things that we think we can do to improve the iteration time, especially in certain happy path cases. What's your favorite thing about Compose you haven't gotten a chance to talk about yet? I don't know. I talk too much, so I if there's something I wanted to talk about, I'd probably just talk about it. I don't know. I'll have to think about that one. But in general, I don't know if you were on earlier, but Gabe asked me a question about animations, and I got super excited and animated about it. But there are some additional animation APIs that are probably going to come down the pipeline. Some of them are already out. Like, so one of the cool things that you can do, for instance, is like if we were changing the size here of this, so like something about the layout of this actual composable or this modifier. One way I could animate this would be like this. So I'm using the animate function here, but let's say it wasn't animated. So let's just say, like, let's say I had something here where I was like width equals, like state dot is even. So if
there's no ternary in Kotlin.
Yeah, I know. I've started writing JavaScript. So if I said like if state dot is even 100 dp else 20.dp or something like that. So it's not it's not some fluid value. I'm just going between here. So I could let me just change this to width. One of the things I could do is I could wrap this expression with animate. And so that would work. And that would be an example of like what we did earlier. But something else I can do is I can just keep that like that. And I can say dot animate content size. And that'll do a layout animation as this changes. And the cool thing is like this can then be a result of something other than me just like setting some numeric value here. So this could be from, if this was like a row or something, for instance. So like if we did this column, so let's see.
And to Dev Senior Souza, who says it's like magic. One of the cool things is that all of this stuff that Leland is doing right now, I bet you could just pop into the source code and see that it's actually not using anything internal or protected. You could create your own modifiers and extensions that are as magical for whatever purposes you want as easily as they built them.
Yeah. So like one of the cool things about this is like I could, this content underneath column could be changing dynamically. And so like me putting this modifier here is going to cause that to animate based on that content. And that's sort of all you have to do. And so that's like one API that, that's pretty exciting. And there's similar things that are being worked on that I think will be just as exciting.
So SwiftUI has a really interesting one called, it's with shared geometry, matched geometry, something like that. And it's similar to this, but it's used for shared element transitions, where you use some sort of a global object or tag between the views. And then when you go from one SwiftUI tree to another, it will do a full transform similar to the shared element transitions that, but with a more modern SwiftUI composable like API instead of the totally insane lollipop shared element transition API. Is anything like that coming to Compose?
Yeah, so that's something that we're thinking a lot about. One of the things that we're considering, so shared element transitions is really difficult. And like, I guess one of the things that we're trying to be cognizant about is not just building a shared element transition API and then hoping we did it right. But instead figuring out like what the right primitive APIs are to enable that type of thing. Because shared element transitions kind of go counter to a lot of like how a declarative like UI system works in the first place. And so like one of the things that I think enables this is we're considering creating an API like this where we basically, so none of this is done yet. This is all just sort of like theoretical, but it's something we're thinking about where like we could let's just call the API compose, right? And so then I could have, some text here or something. And what this returns, so basically me calling this, it executes this composition, but it doesn't place it in the hierarchy. And so then the idea is that placeable is then something that you can then place somewhere else. And then that will place it in the hierarchy. And this, I think, is the fundamental building block that will enable shared element transitions. And I think that there are APIs that you can build on top of this to make like a really convenient shared element transition API. But the nice thing is that if someone else had a better idea or something, they might be able to build their own shared element transition API that utilize this in their own way. So actually, I forget who it was that asked, but someone asked if there's anything I'm excited about. I can't find the question, but someone asked if there's something I'm excited about, and this is an example of something I'm excited about that isn't done yet. Yeah. So what's going on here? Match. Okay, this is the match geometry effect. Yeah, I actually haven't looked at this UI. I should take a closer look at it at some point. Yeah, I mean, definitely Swift UI has some very, very clean APIs for certain things. Could you explain subcomposition? Sure. Yeah. So, subcomposition is a lot like this, except you don't have the placeable. Oh, sorry. Gosh, gotta get better at that. So subcomposition is a lot like this, except you don't get this capability. So you don't get this like placeable thing that you can put somewhere in this tree. What subcomposition is instead is like you kind of have to pass in like a new root, and then that's like the root node of the tree that this composes into. And then you could do something with new root or something if you wanted, but that's sort of the difference. They're kind of similar APIs, but the one I just showed, it has some really neat use cases. General style in the XML way, we have the style files inside values and style to give the widget. Oh, I guess this is a conversation further up.
I think I was kind of half following that YouTube conversation. There's a Google repo with a bunch of samples. It's goo.gl, I think, /compose-samples.
Yeah.
And among them, they have several that really focus on theming. And so the answer is there are definitely ways of doing themes. They generally leverage ambience. So your theme is like an ambient, which also makes it really easy to do things like have a dark theme or have a brand theme. And you can, they outlined for all those samples there, they outline what they focus on, and several of them focus on theming. So if you have any questions, those are great resources. And the answer is definitely possible.
Yeah, theming is one of the things that in the compose world, it's pretty different from the Vue world in an intentional way. So like there are a lot of like the theming system in the classic Vue world of Android is like incredibly flexible and like extensible and complicated, and it's neat. There's a lot of really powerful things you can do with it, but we intentionally underpowered theming in Compose, and so it's not extensible in the same way. And the idea is that you can follow our like the general template that we have done to accomplish theming, and you can implement your own theme if you want, like from scratch, and like that's certainly doable and easy to do, but it'll be separate classes, separate code, and completely independent from like the material theme, for instance. And so that was like an intentional choice that we made. All right. Yeah, what do you think, Gabe? Do you want to we could do some more coding, or do you want to wrap it up? I don't know. We were scheduled for 2 hours and we've gone over that, but we can go as long as you want.
I think at 2 hours and 20 minutes, I think we've given ourselves plenty to chew on for this one. definitely looking forward to doing this some more, but for the sake of letting everyone have their evening and getting some dinner ourselves, maybe it's best to wrap this one up and figure out what we want for the next time. But man, this was awesome. I mean, we got MvRx fully integrated into Compose, and that almost feels like just that was the first few minutes, and it was working. It worked the first time we ran it, so that was pretty fun. And then definitely there's so much more to talk about and uncover here, and we'll be doing this both us and with the community. And man, how exciting! That's all I have to say.
Yeah, definitely. Well, thanks for coming on. We'll definitely we'll do this again with some new stuff. But yeah, I appreciate it. This was really fun. So this is stream number 2. I'm gonna keep trying to get better. We had a lot of audio issues earlier on, so apologize for that, and then also some stream quality issues. Anyway, the next stream I'm gonna be doing will be tomorrow, and this will be part of my Compose compiler series. So I'll actually be doing my job live for you, and I'll be working on some interesting stuff. I just started working on a new project in the compiler, and so we'll talk a little bit about that. And feel free to tune in. It'll be tomorrow at noon, I think. Let me just verify that that's the schedule.
I'm sure everything will work the first time you run it, just like it did for us, right?
Ooh, no, this is gonna take a long time to get working. But sorry. Okay, so it'll be at 1 p.m. Pacific Standard Time to 3 p.m. tomorrow. So definitely tune in then. And I appreciate everyone on the chat bearing with the poor connection here.
Yeah, really appreciate it. I'm humbled that you all sat around and listened to us talk about Compose for over 2 hours. So thank you. We are always available on Twitter and wherever else you can find us. If you want to just talk or have some ideas, or if there's something you want to see us talk about, pair program, or you want Leland to talk about, we are available.
Yeah. Awesome. Okay. Thanks, everyone. See ya.
Thank you.